Christian asked me to give this talk, so expect a couple of complaints from me. He was aware of it, so like, anyway, it's not all like Trilinos' fault, right? But anyway, so what's deal.II? Deal.II is one of the largest open source C++ finite element libraries. We support like anything from very beginner users, like for teaching materials, to like very large ones. We are like highly adaptable. We have adaptive mesh refinement like built in, as opposed to like the talk we heard before. So you can on the fly refine your meshes. We support all kinds of mesh types now, like mostly with hexahedra and stuff. But in recent years, we added like simplices, pyramids, everything, wedges, whatever you want. And yeah, we consider ourselves like a modern C++ abstraction, and probably have like really good documentation. So we also got like the SCM prize last year for impact on the general scientific computing landscape in terms of teaching and don't reinvent your wheel. It's a little bit older code developed. Started to be developed around like 2000 by Wolfgang Bangert, and yeah, it has grown pretty well since then. Relevant for this talk is a little bit that it's used in a lot of universities and mostly used on CPU systems. So there were like some efforts, of course, to also run on modern supercomputers with GPUs. But that has not yet become the focus of all the developers. So it's slowly coming. I mean, Timo just joined us. He just talked a little bit more about GPUs in deal.II in the Cocos session, in particular using PETSI and also then the matrix-free framework that we have. Yeah, furthermore, it doesn't have any direct funding, so every developer needs to fund their own. So that's also like we develop what every developer needs. Okay. How does deal.II look like? That's like our general graph, which we like to show. So we implement pretty much all parts of a finite element application that you might want to have. So starting at the top, you look at like, okay, maybe we want to read in some cat files from Open Cascade. We can then define some manifolds on top of that, define a triangulation with that, define finite elements, mappings and quadrature points, and then map that into more lower order parts of the ecosystem, where we then where we have a doof handler, FE values, and all of that stuff. And then where Trilinos and other linear solvers come more in is here in the linear systems, linear solvers part. And you see a couple more boxes here. So we have an explicit dependency on Cocos, and for the most part that is for our portable matrix-free part. So we don't necessarily rely on this structure with like having linear systems, linear solvers separated that much. So we have support for matrix-free and matrix-based. And of course, like Trilinos is more interesting here for the matrix-based part. Okay, so talking a little bit about dependencies. There are like a whole lot because we don't want to implement all of these capabilities on our own. So you see something like ArborX, for example, and explicit dependency on Cocos, mentioned a bunch of times here. For the mesh distribution, we use pforest, for example, and then have Open Cascade, linear algebra, then do like Trilinos, for example, and then multiple packages that can use deal with automatic differentiation, for example, like SimEngine and others. Okay, so what about Trilinos? I spent a lot of time just introducing you to the general deal.II framework, so I guess it's time. So as I said, deal.II started as a garage project, more or less, coming out of a PhD thesis and then just putting on a website, and has gained users since then. So around like 2008, people discovered that there was Trilinos and also started to get interested more in MPI. Again, Timo worked a lot of the MPI stuff in his PhD thesis. And yeah, it has been pretty popular since then. As I mentioned before, there is also PETSI. So these two are our big, or like the only parallel linear algebra packages. But we don't just use Trilinos for linear algebra. You can see here, of course, the required dependencies are mesostastical, Epetra, FPEC, and ML. But then, like on the right-hand side, you see like a bunch of other things like Knox, Roll, Saccaro, CCAS, and so on and so forth. But I mean, if we talk about Trilinos, to be fair, it's mostly like linear algebra. Okay, we supported versions for a long time. So our minimum version is 13.2, which is brings its own challenges. I don't even know when that was released, but generally we try to support whatever was in like latest releases of common operating systems, and the packages don't get like updated that often. So that's still very relevant for us, and oftentimes like a pain point also, in particular if we want to update Cocos, because of course it needs to be compatible with whatever we're doing in Trilinos or with Trilinos. So up to yesterday it was true of 13.2 to 16.2. Yesterday we finally merged something that we can actually configure with Trilinos 17, and so then we require either Epetra or Tpetra. But of course this forces us to think out Trilinos interface to a good extent. I mentioned that before. Why is Tpetra relevant for us? Trilinos and PETSI are basically the two packages that can give us parallel linear algebra. We have our own parallel vector types that we use, say, for the matrix tree implementations, but we don't have any matrix implementations. So we have our own solver CG, but no preconditioners. So it's oftentimes relevant even in a geometric, in a matrix-free framework, just because we need to do something on the course grid. And it depends very much on what the course's grid is and how big it is. If we can just solve it on the CPU, or if we want to solve it on the GPU, if we can just iterate through it like with the iterative solver within or whatever, there are a lot of opportunities, of course, but ultimately this is really important, and we ultimately oftentimes want to use algebraic precondition, and that needs a matrix. Okay, other parts is Trilinos 17 was just released, so maybe users don't really care, but we need to be prepared for the future package managers for deal.II care, again, that we want to, that we can package Trilinos 17, so staying up to date is important. We want to move more towards GPU support, since that's the future, also in terms of like all the supercomputers, and yeah, generally just being nice to other users. Okay. From the timeline, it has been a long time, and it also shows a little bit how difficult it was, or like how difficult it is to find support for doing that, or what the interest is. Like we started in 2019, like Tpetra's Rapis vector. But since then, it was like we had a new vector interface, so we were interested in all supporting that to using Tpetra with that. But then it was very slow to make any progress. So we thought we felt an urge again in 2023 to implement something. So we did a sparsity pattern, and then Jan-Philipp Thiele and Sebastian Kinevik, that was also mentioned yesterday, helped then with finishing a sparsity pattern, and then sparse metrics, and then I completed last year the precondition AMG Mühle. And as you see here, everything is in the Tpetra Rapis namespace, and that's a little bit different from what we are currently doing. So ultimately, users are used to having Trilinos Rapis. So if you enable Trilinos as a dependency, you expect you can use Trilinos Rapis. But due to historic reasons or slow development, and you can't do everything at once, we developed Tpetra Tpetra wrappers in its own namespace, also because, of course, it provides more functionality, like different scalar types and then different memory spaces. And basically, we had like also this Epetra wrappers vector, which was also this new vector interface where that was also used in Tpetra wrappers. So we just throwing that away now because no one wants to use that anyway. Oh, no one used it. But that's generally now the challenge for us. So we kind of support both sides. So the left-hand side is still Trilinos wrappers, Epetra based. The right-hand side is Tpetra. And can we provide now like any kind of smooth transition? Because we have this wrapper approach for external libraries, so we don't really want to expose the interfaces. So people just say, okay, I use these wrapper types. And this is, of course, a big problem because like ultimately, Epetra and Tpetra have different interfaces, and it's not designed with like backward compatibility in mind. I mean, at least that feels to me sometimes. Okay, so what can we do? The idea was we tried to copy the implementation somewhat to Tpetra, so we get the interfaces, and then just like kind of figure out what changed from Epetra to Tpetra in terms just of naming of functions, interfaces, and stuff. Doing that, we ran into like RCP, I will say nightmare, because it's like, I mean, for me at least, it's really annoying to deal with that instead of making all the objects having reference semantics. Like Cocos view would have been like a more natural way to dealing with that, but I mean, there's also like the incompatibility issues if you want to talk about const and non-const objects. So what does it mean to have a const RCP pointer, and what's the conversion there? I'm coming back to that, of course. Okay, so we kind of did this first point. The second point is making Trilinos wrappers aliases for Tpetra wrapper classes. There's a pull request for that. Since we merged general support for Trilinos 17 like yesterday, I'm trying to push that one through now. Yeah, and then for future references, in the future, it's interesting to see what do we want to do with Tpetra wrappers and what do we want with Trilinos wrappers, because Trilinos wrappers means double and memory space host, but that's not what you really want as a user. So if you look forward, you probably want to use the Tpetra wrappers namespace, but maybe we can deprecate it at some point and just give the template arguments and also to Trilinos wrappers. But that's a difficult path for us because that breaks code for everyone again, even if you can maybe do CTAT. But yeah, we'll see. We don't have really like any good solution there. I think for now we're just happy if we just can use this alias. Okay. So now I just wanted to talk about different stages of the process of using Tpetra, basically, and all the issues that we were running into. I think I reported most of them in some way or fashion to Christian, so I'm apologizing a little bit already that he is always like the culprit, or feels like the culprit here. For example, we had starting maybe at the bottom with the enabling Tpetra int with Tpetra and Epetra gave us interesting issues in Xpetra that like a Thyra header was not found. I heard that Trilinos is interested in doing patch releases, so that's why I think this one, I didn't report this one, but we should probably do. We have problems with Epetra and Tpetra, enabling them at the same time for some compilers. So until like quite recently, that was not possible. So I think that there was fixed, like this pull request was merged like last year, so like in 16.1 or so. And then on the deal.II side, we have a little bit of a problem that we need to decide on our own what kind of global ordinal type we have, and that needs to match Trilinos right now, because we kind of tried to assign pointers somewhere, I think, but we need to look at that carefully. What's a little interesting here is we are supporting Trilinos all the way back from 13.2, and the default changed in 13.4, so that's a little bit of an annoyance. So like someone that uses a old version really needs to pay attention what ordinal type to enable in deal.II, and that depends on the Trilinos version now. Unfortunately, a little bit, but okay. Okay. Next part, assembly. Assembly in deal.II has multiple ways to do that. So you either manually write the assembly of the matrix, use like some kind of matrix creator framework, which gives you like predefined matrices. You have a mesh worker framework that's like task or thread-based. Matrix free, of course, where you just write your own operator, you don't create any matrices, and then a portable matrix free, and only the last one really uses GPUs. And that is, of course, a little bit of an issue that we don't really benefit from having any objects on the CPU when it comes to assembly at this point. So we would need to figure out like a different framework that could do that to really leverage it. Maybe we could build matrices through the portable matrix-free framework or not. So what it looks like is basically like this. For setup systems, then you would declare like a couple of vectors. You would reinitialize them with whatever map you have, and then the interesting part is then is a sparsity pattern. In this case, this is the nice case. We use the deal.II object, the dynamic sparsity pattern. We say make sparsity pattern, so it gets a doof handler, which knows about basically about everything, and so it can just like run through the mesh and figure out what the sparsity pattern looks like, and then we can say, okay, distribute it across MPI ranks, and then reinitialize our, in this case, Trilinos wrappers matrix with it. So it's nice because we don't see a Trilinos wrapper sparsity pattern. If we see one, though, then there is a really hard break from Epetra to Tpetra, which is that in Epetra, the sparsity pattern was dynamic. So you didn't need to care about allocating the correct number of entries, and so that's like why a lot of users don't use that. Like they just say, okay, we don't like allocate anything, we just say the guess is 0. And go with that. And then Tpetra at some point disabled that because you can't allocate well on the GPU. And so keeping in mind now that we just want our Trilinos wrappers to be aliases, for the Trilinos wrappers, this creates somewhat of a problem, and so it's not super clear how to deal with that, because whenever you just say, okay, use the same interface, then in almost all cases you'll get like Trilinos to complain you can't do it. But that ship has sailed, so should we deprecate like the whole class? Should we just say, okay, Trilinos wrapper sparsity pattern doesn't exist anymore? Maybe we should try to deprecate any constructors that have a guess or without a guess, either way. Or should we just wrap it under the hood? Like, should we just say, okay, we use a deal.II dynamic sparsity pattern under the hood, and only if you are done or compressed, then we will transfer to the Trilinos object. I think in the end, like the current favorite is just to say we deprecate interfaces that don't play well. So I think what we want maybe is like you have to provide a guess. And if that's 0, that's suspicious enough that you need to think about it, and that 0 is not a good choice. But maybe we just want to require that you externally build a dynamic sparsity pattern, like in this previous slide. This is also there, but ultimately that means that we break a lot of codes. We have a deprecation path, but that's a problem. Okay. Okay, and then I talked about assembly already. That's basically what the manual approach that we teach the most looks like. Pretty much all our examples look like that. So you have a FE values object which knows everything about about the cell and like all the shape values, shape gradients, so you can assemble the matrix, and that is intrinsically CPU. So this approach will not work on a GPU at all. I can't see how to do that, but there might be, we might be able to wing that with one of the other approaches. Issues here, we discovered that a little bit late. We in deal.II don't have any call to say, okay, I start assembling a matrix. Now we just start doing that. And then we say compress to communicate entries. Resume fill is documented to be collective, but isn't really, which is nice. So we can just start assembling things. And so that worked in Epetra and in Tpetra now. Fill complete, on the other hand, is actually collective, so we need to know if someone did work, and so because we don't have a step to say we started assembling, that means we need to do some more MPI communication to get a consistent state across MPI ranks. Also because we can't call fill complete in a row, multiply in a row. So that's something that we need to do. But so that's something, I mean, it's documented as resume fill is collective. So if that will actually be collective at some point and has blocking MPI behavior, then that would probably break us again in some way or the other. Unless we require now deal.II for all our other vector types and matrix types that we need to do that, which kind of breaks every single code that we have so far, of course, again. And then I asked the question if there's a better assembly approach already. That's maybe not so much of a Trilinos issue or question, rather just saying we don't benefit there very much from Tpetra. Then looking at preconditioners, Mühle doesn't have quite the same interface as ML. There was some discussion in like a deal.II pull request with respect to that, but I think it doesn't really matter that much. It's some minor incompatibility. I think like if you just create a default object, then it mostly works. Anyway, it just doesn't quite have the same options, of course. Then I mentioned before, const correctness is like somewhat broken for the Tefos objects. Because you can't create like a Tpetra preconditioner from a const object because it takes a non-const Tefos operator. But we can work around that, just do constant cast, of course. But that would be maybe nice to fix. Okay, and we also have a pull request for like a Frosch interface. I mean, it uses Xpetra interface right now. Maybe Xpetra doesn't need to exist anymore. But yeah, anyway. And then currently everything is Tpetra CRS graph. So I need to understand what the difference is to the FE CRS graph and if it makes sense to replace that, if that has benefits or not. I've not really been able to dive into that too far. Performance hasn't really been much of a concern of mine yet, but I still wanted to just try something, give some numbers. So this is just the isotropic linear elasticity problem, 10 to the 5 degrees freedom, 100 time steps, CG solve, and then we use identity or SSR preconditioner. Since I've not been able to use Mühle or ML for whatever reason, I talked with Jonathan yesterday about that a little bit, so I need to understand what's going on. But so I was running this on Frontier. Epetra gave me like around, identity was like 100 seconds and SSR like 72 seconds. It was interesting. Well, I okay, going to Tpetra, it's very interesting that there is pretty much exactly 30 seconds in between. So I don't know if that's somewhere in our interfaces, quite likely. I need to investigate that. And then going to HIP, we gave like the same time for both of these options, which was interesting. But I mean, we don't really gain super much at this scale, at least, which I don't know if that's expected or not. I need to look if launch latency is an issue there, or like on our side that we do a bunch of copies, or if there are other copies or limiting factors. That was just interesting to me, but maybe some of you guys have more of an expectation what I would see for this setup. But yeah, I think that brings me to the end. As we have already seen in the community, even a couple of weeks ago, the change in the sparsity pattern is probably the biggest issue for user codes, in particular maybe in Europe, I don't know. And I think for us, really, the Trilinos 17 forced our hands a little bit to go from Epetra to Tpetra. Otherwise, there is really not that much of a motivation, and probably we would just have carried on with like this process for a couple more years. But now we're kind of like trying to rush, or at least I have used this week quite a bit to rush things a little bit. So, I mean, ultimately, everything works with Tpetra. Like, you just need to accept that there are incompatibilities, in particular for easy use cases where you don't really need to expose like or use every interface we have in deal.II for the Trilinos wrappers. It should just work at this point. But I still wouldn't recommend people really to use it, because there's, I mean, unless they want to experiment, because it's not super stable. Anyway, so if I try to run C-test right now, okay, I get 76% passing out of our 530 tests that use Trilinos, or at least mention Trilinos in the test name. So maybe it's not that far away, but it's quite tedious to go through all of that. But yeah, with that, I'm happy to take some questions if I have time.
We've obviously ran long, but maybe one quick question.
Are you, for the Mulu, are you using the ML to Mulu parameterless translator?
No, I'm just using whatever defaults.
Oh, okay.
Oh, you mean in general?
Well, I mean, because there's a parameterless translator that will take ML style options and turn them to something Mulu will use.
Well, I mean, ML doesn't, exist really. They are separate objects, right, for us, like separate classes. So we don't try to do any kind of translation. It's not like user codes would use both of those at the same time.
No, I think what he's saying is that if your users want to continue using ML parameters,
Yeah,
you can translate them to Mulu parameters.
Okay.
That's how it's done.
Yeah. Okay.
We should provide a method where, from a parameter list, we say whether
there is one.
There is.
But
So you should be able to hook up the logic to like auto do that for your users, so that they can use the old ML syntax and get out.
yeah, except that we don't expose the ML syntax in the first place. So we have an additional data object where you can set that, but then we would, I don't know.
And so if they set that in the data object, then they get it. If they don't, they don't. It's up to them.
Yeah. Huh?
Alrighty, let's thank Daniel again.